So after several months of getting distracted by other projects like my go-kart, still a good project, and other things around the house like building a deck in my backyard, I am finally going to seriously get started on rebuilding my C5 Corvette, fixing the front end and building this thing up and modifying it to be a really cool autocross car that incorporates a lot of 3D printed parts. So in today's video, I plan on starting this process with a small step, but a really cool step, because I kind of want to show you guys the process of what the power of 3D printing can do for a build like this. The thing I'm going to make is a very simple tool, but it just kind of is the basis and a rudimentary example of how cool 3D printing can be for custom projects like this. So if you are new, quick little recap. I bought this 2001 C5 Corvette, 6-speed manual, of course, from an insurance auto auction back in November of 2018. So I've had the car for over 2 years now, and I've gotten it registered. I've fixed up the front end a little bit more than what it was when I got it. The impact bar was damaged, so I replaced that. Fixed up the front bumper, got the driver's side headlight glued into place so I could at least drive it. And I've actually been driving this car on the road quite a bit, enjoying it, but now I'm ready to finally start tearing into it. The car is pretty mint other than the front end. It's got 55,000 miles on it, and I've always loved Corvettes. I wanted a 6-speed manual stick shift car, and I love V8s. So what a better way to do a build than with this car. One of my other big passions is 3D printing. I started doing it in college with my good friend Will, and I do it every day for work now as a mechanical engineer. So my plan is to combine my two passions, Corvettes and 3D printing, into one with this build here. So the first step that I'm going to be doing in this video has to do with the hood. Now, I'll take you over to the car in a second here, but basically what I need to do first to this car is I want to get the front end situated, repair all the damage, because even though it looks mostly squared away, when you look closer, there's a lot more damage that needs to be fixed. It's kind of like a 20-foot car right now, if you will. So I'm going to bring you guys over to the car and exactly explain what I'm going to be doing in this video with this little 3D printed part that is very simple but really important. Alright, so welcome everyone to Nat Automotive C5 Corvette. So you can see here, this was the main area of damage where this car got hit. Boom, right up in this way. Totally wrecked this headlight, wrecked the hood, and it also wrecked the inner fender here underneath the outer fender. So you can see how bad the body panel gap is right here. This thing is totally shifted back. Can you see that? Yep. So it's shifted back. It's actually even rubbing on the door every time I open it with the door. But you can see how bad this hood gap is right here. Actually up here, it's not too bad. It actually looks really similar to the one over there. So that's what's going to be involved with this 3D printed part today. So over here is the non-damaged side, the passenger side. And right here, from pictures that I've looked up online of other C5 Corvettes, other C5 Corvettes I've seen in person, this fender hood panel gap looks pretty factory, pretty consistent. It's about, I don't know, I'd say 3/8 of an inch. No, not 3/8. Yeah, maybe 3/8 of an inch. So, like I said, this tool I'm going to be making is very simple, but it's going to really help me rebuild this front end and get everything situated. So to further explain what I mean, let's go ahead and open the hood. Squeeze on in here. Open my very crinkly, damaged fiberglass hood, which is actually an aftermarket hood, believe it or not. Alright, so now we got the hood open so we can uncover some more damage. So you can see just how screwed up this hood is. It's split all the way down here. I basically just shoved glue in here and squeezed this together so this hood could be used in the time being while I got a new one. And you can see this down here is just all sorts of screwed up. This whole bracket, I don't know what you call it, mount on the hood, delaminated from the entire hood. So you can kind of see it right to there. So there's just full on, you know, this is just all held together by strong Gorilla Glue right now, but this whole section here is just so messed up. So when this whole bracket mount piece came off and I glued it on roughly, I tried to line it up as best I could, but this thing is just, you know, it's long gone. And it's kind of unfortunate because this is an aftermarket high-rise hood, so if you look at this hood here, It's got this kind of exaggerated, you know, rib, or kind of looks like a set of abs almost, center section. And then this one, this is a stock C5 Corvette off of a Z06. It's got that same like rib, but they're just not as pronounced. So I wanted to repair and save this hood, but it's just not in the cards. Anyways, back to the topic of the video. So this whole thing's damaged. I need to take this off, but even though that this hood is damaged, the panel or the fender hood gap over there looks pretty good and consistent. So I want to build a tool, kind of like a gap spacer tool, that will tell me what this side needs to be. Now, why do I need to make that? Well, in the accident when this headlight got hit and this whole side got damaged, it really screwed up this inner fender. So you can see here, these holes are all ripped out. This inner fender is cracked. It's way cracked down there. You can't see it. So I need to replace this whole inner fender, and I've got one. I've had one sitting here for a while now. I just need to actually do it. So this is a replacement inner fender that was pulled off of a wrecked C5. And the tricky thing is with these cars, these inner fenders are epoxied and glued to the frame rails of the car. So the tricky thing is when you replace the inner fender, because the outer fender mounts to the inner fender, the way you mount this determines how the outer fender mounts and determines your door gap, your hood gap, your front bumper gap. So it's really important to mount this inner fender correctly. So what I'm going to be basically using is using that side as a guide. So I'm going to go ahead and close the hood, get it all latched down and locked, and I'm going to measure in several places with my calipers here what this gap exactly is. And then I'm going to go over to my 3D, or not my 3D printer, my computer, design up a really simple just block tool that will help me you know, get a physical object and representation of what this gap is, so that when I do replace this inner fender over here, I have something to go off of and use as a reference. Now again, this is a little bit overkill for how simple of a tool this is. It's kind of like, you know, killing a fly with a shotgun, so to speak. But I just wanted to use this video as an example of how 3D printing and the versatility of being able to create whatever you want, whatever shape and size you want, regardless of if it's available to buy. You can create really custom tools to help you on all different kinds of builds: car, go-kart, house, you know, whatever you want. So this is just a rudimentary example of that. In retrospect, I probably could just create a spacer tool, you know, using like some washers, gluing some washers together, or, you know, out of some wood. But, you know, I've got a 3D printer, I know how to use it, so I figured, you know what, let's just use an example here and show you guys exactly kind of the first step of incorporating a 3D printed part with this car. So I'm going to use my calipers, like I was mentioning before, and measure, you know, about 3 to 5 points along this gap here where the fender meets the hood, and then take an average, and then that's the spacing here we'll use to make our tool. So the reason I'm being very particular with this little task of creating the spacer tool is because how you mount the new inner fender is determined based on your hood. Now, if my hood isn't set right, then this isn't going to be set right. So when I go to install the new hood, basically what I need to do is, because this fender is good, I need to mount the hood and get it lined up with this fender. To do that, I need that spacer tool. And then when I know the hood is lined up nicely, then I can use the hood to mount the new inner fender over here. Because you basically take your new inner fender, mount it to the outer fender, and then while those two are mounted together, you mock it up on the car, and then get your gap close, and then you use that as the point. Okay, that's where I need to glue the inner fender to the frame. Alright, so let's go ahead and get my calipers here. So I've got my calipers. Now let's go ahead and take some measurements. Alright, so we'll take one here right at the beginning. So that's 0.31 on the dot. Probably write these down. Alright, got a piece of paper. So I think I said the first one was 0.31, so I'm just going to double check me there. 0.313. I think I said based on my estimation, it was 3/8 of an inch, so that's pretty good. take pride in my visual estimation skills. Alright, so 0.31, we got 0.28, 0.262, 0.222, and 0.237. So it definitely does get narrower as you go back from the front of the car, and that's probably largely due to the fact that this hood is just so messed up. I mean, it doesn't even mount nicely to the front of the bumper at all. So like I said, that's why I'm going to take an average, and hopefully that'll get us close to the middle of there. So that'll be, you know, helpful when we need to set our new hood to get it set nicely to the undamaged passenger fender. So what I'm thinking is creating a little block tool that's not too long, because this is a curved line here, and because I want it to be able to fit in this gap, and if I create something too long and straight, it's not going to fit nicely in there. But I think what I'm going to do is create something, you know, about this long, about 4 or 5 inches, and probably make 3 of them, like one for the front, one for the middle, and one for the back, so that when I'm setting it, I can have them all in the different places along that whole body panel line there, and have it be as close as possible. And I think what I'm going to do also is create like a little step so that the tool can rest on the outer fender, and then have it, you know, have a little indentation that goes down into this gap. So I'm going to measure this depth here and then mimic that on all of them. So for those that don't know or haven't used calipers a whole lot, you can measure depth easily with this little part that slides out the back of the caliper, and then that length associates with your measurement. So the depth is right about 0.182. Alright, so now we're over onto the computer here. Let's load up Solidworks and we'll create this little tool here. So this is the, you know, kind of the design process here of you go to your car, you take measurements, you reverse engineer your part, so to speak, either with hand measurements, 3D scanning, you know, you name it. Most of the time I just do hand measurements because I don't have an expensive 3D scanner. You go over here, you model your part in 3D, and the software I use is called Solidworks. It's pretty industry standard for mechanical engineering, you know, stuff like that. And then you slice the model, which I'll show later, and then you 3D print it. So I did take an average. Can't really see that well, but the average of all the 5 gap measurements was 0.263 with a depth of 0.182, so that's what we'll be using to make our little tool. Alright, so this isn't going to be a SolidWorks tutorial because that would open a whole nother can of worms as far as videos go, but I'm just going to go ahead and crank this little part out, and I'll show you guys what I come up to at the end. Alright, ladies and gents, so now I have my part. So I went back in and I made this part a little bit taller, so I wouldn't get confused on which, if it was this side or this side, that is my gap tool. So now that this is a lot taller vertically, I'll know a lot easier that this distance here to here is the gap that I'm using for the fender and hood. So now what I'm going to do is save this as what's called an STL file. It basically triangulates the model into millions of little triangles, and then import that into a 3D printing slicer software, and the one I use is called Cura. Alright, so now that I got Cura opened up, so basically what Cura does is it takes your STL file of the model you just created and slices it into hundreds or thousands of layers depending on how big it is and what layer size you select, and it gives the printer a roadmap, because basically a 3D printer is a 2D printer just operating in multiple layers. So the first layer it knows to do this, and then the second layer goes up, does this, and then it just keeps following the profile of how it slices the model vertically. So I'm going to go ahead and import in our file here that we made. And one big thing with 3D printing is, and of course I'm gonna talk a little bit about it in this video, but I do plan on making a lot more 3D printing videos in the future that go over in a lot more detail on how to create more parts as I start incorporating it more. But one big thing is when you print something based on the important feature of the part you want is to print it in a certain orientation. So for us, that one little gap spacer that we made is important. So for us, printing that vertically, or putting that vertical or on the top side of the model, not the bottom side, is a lot better, because whenever the surface that is always touching the build plate isn't always as nice. You have to clean it up a little bit, so when it's up on the top of the model, based on how you orient it, it turns out a lot nicer. So I'm just setting up 3 of the different files here. And basically in this slicer software, there's many different kinds of slicer softwares, and the one you use will be determined based on the printer you have. And I have what's called a Creality CR10 V2 printer. So the most common one to use with that is Simplify 3D, or I like Cura the best. And basically, like I said, this is the slicer software, and then this is where you go in and incorporate all of the different settings that you want for your printer. So the material you're using, how detailed the model is going to be, the layer thickness, the wall thickness if you want to make it stronger, the infill density, the printing temperature based on the material, etc., etc. And then you go in, you adjust all that, and you click slice, and then it creates your, for us, a 3D printer specific .g code file. Another thing to consider is when you're 3D printing something, if it's just for an initial fit check, or if it's just a quick part, like for us, this is just a quick part, not a final part, just to use as a spacer. You don't want to make it as detailed, you don't want to create it as dense, because it's just going to take more time and use more material. So this is a pretty low density, and the layer height is also a big determining factor of how long it takes, is the layer height. So we set the layer height a little bit more coarse rather than more fine, because this is just a quick little part we're making. So now the next step is, now that I have the model file sliced, I'm going to take it up to the printer, and I'll show you guys just quickly how I'm setting that up on the printer. Okay, so now we're up in the 3D printing studio. So the file gets transferred from the computer to the 3D printer via an SD card, so that's how I put it on here. And if you're wondering why there's blue painter's tape on the bed, it just helps with adhesion a little bit. Sometimes I've had issues with the prints popping off in the middle, and then it just creates this stringy mess. So the blue tape is just an easy way to help promote adhesion on the bed. And the material we're using, and without going into too much detail, I'll go into more detail on all the different 3D printing materials in a different video, but this one I'm just going to be using a PLA, which is the most basic material you can 3D print with. It's pretty cheap, and it's really easy to print with. The material properties make it really easy to print, but it isn't really strong. It's pretty brittle, and it'll degrade in the sun. But since this is just a really simple part for checking that panel gap with the hood, this material will do just fine. So now I'm waiting for the printer to heat up. Once it heats up, the print will start, and it should take about an hour and 40 minutes. Alright everyone, so the print just finished. As you saw, I went ahead and pulled them off the build plate, got most of the skirt material off. The skirt is just like the extra little footprint piece that surrounds the part to help it adhere. So I got that all off, but here's our little part, designed and 3D printed all within a few hours. So I've already got the other two sitting on the, kind of wanted to show you guys actually how it turns out. So this part right here, this little step where my middle finger is, that's the part that is the gap setting part. And then the other part, this lip right there where my thumb is, that's what sits on the fender to kind of help it rest. So you can see down here, the gap is larger than the average. There's quite a bit of play, but as you go up, it gets pretty tight. I actually had a tough time getting that tool in towards the back. But it works just as intended, so it's going to really help when I need to get this new hood aligned properly on the car so that I can get the fender on that side set properly when I have to epoxy it to the frame. So, just a quick rudimentary example of how you can make a custom 3D printed tool or part for your car or any other project that you're working on. Okay, so that's gonna do it, guys. I hope you guys enjoyed kind of seeing the process of and the power of using 3D printing to make a really custom tool or part for any kind of project, whether it's a car project, you know, a project around the house, whatever it might be, for school or work. There's the really almost the capabilities with 3D printing is limitless. What it comes down to really is the material and the size. But it's a really cool technology to have at our disposal, especially, you know, at home. So I hope you guys enjoyed seeing that. I will be printing actual parts for the car as well, not just tools. So I have a list of all the parts that I'm going to be building out and actually running on the car. I just have to kind of take it one step at a time. And the first step is getting this front end squared away. So I hope you guys enjoyed this video. If you haven't already, definitely subscribe for more content to come on the C5 Corvette. Also, I forgot to plug it at the beginning of the video, but I have an Etsy store up now where I am selling digital download files that you can purchase of a complete design and instruction kit for my custom street go-kart that I built over the past few years. So if you guys are looking for a cool, fun project that's hands-on and you want to build a go-kart for yourself, definitely go check that out. Link is in the description below. So thanks again, guys, for watching, and other than that, I will see you in the next one.